resistors in parallel. How can you replace that with one single equivalent resistor? So here I have 3 resistors in parallel with a battery, and I want to replace that with just one equivalent resistance, and how we calculate that. So the first thing is, what does parallel mean? Parallel means that they are hooked up in such a way that their ends are all at the same potential. So the potential across this, potential across that, potential across that is the same because there's nothing between them. I have ideal wires. Okay, so right here I have the current coming out of the battery as I, and then it splits into 3 things. Using the junction rule, I can say I is I1 plus I2 plus I3. Now I want to go over here and I want this equivalent circuit to have the same current, right? To be equivalent. So if I use the loop rule right here, I just get VB equals I R equivalent. That's just the loop rule. Now, I'm going to solve for I, and I get I equals VB over R equivalent. That has to be true. Okay. Now, if I go back up here and I'd use the loop rule, I can go around this first loop. So if I do that, I get VB minus I1 R1 equals 0. I should have said this. I should have said minus equals 0, but you get that same thing. So around this loop, it doesn't matter what that current is because there's no resistor there. So right here, I have a voltage drop of I1 R1, and I get that. Or if I solve for I1 is VB over R1. I can do the same thing for the next one. Minus I2 R2 equals 0. So I2 is VB, the voltage of the battery, divided by R2. And then I can do the same thing, VB minus I3 R3 equals 0. So I3 equals VB over R3. Now if I plug these into my equation up here, I have, am I running out of room? I'm just going to erase it. So I get VB over R equivalent, which is off the board. VB over R equivalent is equal to VB over R1 plus VB over R2 plus VB, that's a 2, over R3. I can divide both sides by VB. 1 over R equivalent, EQ. 1 over R1. Oh, I'm so sloppy. 1 over R1 plus 1 over R2 plus 1 over R3. And that's the answer.